Welcome back, everyone. Okay, let's dive right into today's explainer. We're doing a deep dive analysis of a truly groundbreaking recent publication from the journal Physica Scripta. And guys, what we're looking at here is a brand new mathematical tool. It's a totally fresh perspective that could, quite frankly, completely revolutionize how we view the universe around us. If you follow modern astrophysics at all, you already know that our understanding of the cosmos has some pretty massive, glaring gaps. Well, today we're going to unpack a newly proposed solution that attempts to bridge those exact gaps using nothing but the elegant language of mathematics. You know, every time we point our telescopes at the sky, we are confronted by this vast, dark, deeply mysterious cosmos. And as incredibly advanced as our current physics models are, they honestly struggle to explain what makes up the vast majority of that space. We look out and we see galaxies spinning at terrifying speeds, right? We see the universe expanding at an accelerating rate. But the visible matter, the stars, the planets, the gas we can actually detect, it just doesn't provide enough gravitational pull to hold it all together. And it certainly doesn't explain the expansion. So to make the math work, standard models rely on invisible placeholders, dark matter and dark energy. They're essentially massive cosmic mysteries that we can't see, we can't touch, and we can't directly measure. But what if we've been looking at this entirely the wrong way? Seriously, what if the dark universe is simply a massive misunderstanding of how matter actually moves? We're actually going to skip our traditional agenda today because I want to pull you directly into the core of this mystery right now. Just think about that question for a second. What if the missing pieces of our universe aren't some invisible ghostly substances hiding in the dark, but rather a flaw in how we calculate the movement and interaction of the matter we can actually see? Section 1. The Mystery of the Dark Universe.
Section 2. The Alena tensor explained.
So, the Alena tensor. This is a mathematical tool explicitly designed to link gravity, the movement of matter, and quantum physics into one unified language. Now, normally in physics, these areas are kept strictly separated. It's like two different worlds. You use one rulebook for gravity and the massive sprawling cosmos, and a completely different rulebook for quantum physics and the incredibly small stuff. The ambition of the Alena tensor is absolutely breathtaking because it attempts to use a single, unified mathematical language to explain wildly different situations, perfectly bridging the gap between the incredibly large and the incredibly small. And here is the core difference in how these models view reality. It's a real game changer. In the standard model, the effects of matter are often heavily simplified. It's treated almost as if it's static or rigid. But in the Alena model, matter is never seen as immobile. It's constantly rotating, it's deforming, moving, and interacting with itself. This incredibly dynamic, swirling new perspective argues that matter's continuous, complex movement fundamentally changes everything about how we calculate its gravitational impact. Section 3. A new galactic gravity. So let's look at the exact mechanics of this new galactic gravity. Step 1. A galaxy rotates. Simple enough. Step 2. Its stars and its gas do not remain frozen. They move dynamically within that system. Step 3. This internal, swirling movement actually redistributes energy and rotation throughout the entire galaxy. And finally, step 4. According to the Alena tensor model, this internal movement and organization naturally create an effect of extra gravity. Put simply, the force that keeps stars from flying out of their high-speed orbits might just come from this complex organization of movement. That completely removes the need to invent a hidden dark matter substance just to explain why galaxies spin faster than classical physics predicts. Now, I know what some of you are probably thinking. Is this just wild theoretical guesswork? Actually, no way. This new mathematical idea has already been tested on over 100 different galaxies. And the results? They closely match and in some specific cases even beat alternative models that have been proposed in the past, like the well-known Mond model or modified Newtonian dynamics. So the data backing up this tensor is already showing incredibly strong potential. But remember, the universe's mysteries aren't just about dark matter holding galaxies together. Section 4. Dark Energy Reimagined. So, how does the Alena tensor tackle the second half of our big cosmic mystery, the accelerating expansion of the universe? Well, this just brilliantly illustrates the elegance of the whole model. In this framework, dark energy appears naturally as a normal property of physical fields. It is not an artificially added term. See, in standard cosmology, physicists literally have to slap a specific, extra mathematical term onto their equations just to account for the universe expanding. It's kind of like a mathematical bandage. But with the Alena tensor, this expansion energy emerges organically within the equations themselves. It treats dark energy simply as an inherent property of the physical fields, so you don't need any artificial forcing to make the math work out. Okay, so it elegantly handles galaxies, And it naturally explains the expansion of the cosmos. But I really want to shift your perspective dramatically for a second here. What about the infinitely small? Does this massive galactic scale mathematical framework just completely fall apart when we look through a microscope? Or does it hold up?
Section 5. From the cosmos to the quantum world.
This right here is where the true ambition of the Alena tensor absolutely shines. It's attempting to bridge the massive scale of galaxy clusters all the way down to the absolute smallest building blocks of reality. The exact same mathematical method used for galaxies also works perfectly at the microscopic scale. It describes these microscopic quantum vortices. And what's super incredible is that in their structure, these tiny vortices resemble elementary particles. Within this framework, mass itself might actually appear on its own, materializing simply thanks to the internal organization of those vortices. So this model perfectly links rotation and fundamental properties in a way that recalls known mechanisms in physics without contradicting them. It is literally an elegant mirroring of the macro and the micro. Now, let's take a quick step back. As your guide through this explainer, it is absolutely crucial that we maintain our scientific objectivity. This is a highly promising track, for sure, but it still requires strict scientific verification. While the Alena tensor is a gorgeous mathematical model that gracefully removes the need for invisible cosmic ghosts, it does still have work to do. It needs to explain other important phenomena, and most importantly, it has to be rigorously tested and independently confirmed by other researchers in the field. So for right now, look at it as a highly promising avenue of exploration, not a totally settled fact. Which brings us to our final takeaway. Remember this name, the Alena tensor, because it is very likely we are going to be hearing a lot more about it in the near future. As we wrap up this explainer, I want to leave you with one final thought to chew on. If a single, unified mathematical tool can elegantly explain both the spinning of immense galaxies and the swirling of microscopic quantum particles just by accurately accounting for how matter moves, could the Alena tensor actually be the ultimate key to unlocking the true nature of our entire universe? Thank you so much for joining me today, and as always, keep questioning the cosmos.